Alright, so this is science paper 1, physics or science paper representation. So in this representation, I'm going to devise with you under waves and electronic propagation. Okay, so let me not forget, if you're new to this channel, kindly subscribe for more videos like this. So the question is saying ultraviolet radiation is one component of the electromagnetic spectrum. Question 1, which is Roman numeral number 1. State the name of two components of electromagnetic spectrum that have a smaller wavelength than ultra radiation. Okay, so I'm going to give you a mnemonic, which is my roast means is very unusual, X mass gift. My roast means is very unusual, X mass gift. Where roast is radio wave, then as for mains, it is micro wave. Then as for is, it is infrared. Then as for V, it is what? Visible light. Then followed by unusual. So as for unusual, it is ultraviolet, which is the same one. Then as for X mass, it is X-ray. Then as for gift, it is gamma rays or Y rays. So now, on this part A, when you move from radio wave going to gamma rays, the frequency increases. Okay, so as you move from radio waves going to gamma rays, the frequency increases. Then when you move from gamma going to radio waves, the wavelength increases. So which means radio wave, it has high wavelength. Then as for gamma, it has short or shorter wavelength. But when you move from radio wave going to gamma, the frequency increases, which means gamma rays, it has high frequency. Then as for radio wave, it has low frequency. So now this question is saying, state the name of two components of the electromagnetic spectrum that have a smaller wavelength than ultra radiation. Remember I was saying the wavelength increases from gamma going to what? Radio wave or radio waves. So now unusual here is representing what? The ultraviolet, which means the X mass and the gift here is the only two components which have smaller wavelength than ultraviolet radiation. Now X mass is representing what? The X-rays. So I'm going to say X-rays or X-ray. Then as for gift is representing what? The gamma radiation or gamma rays. So those are the two answers for Roman numeral number 1. Then as for Roman numeral number 2, state one useful application of ultra radiation. So state one useful application of ultra radiation. So the first one I'm going to say, in the treatment of cancer. In the treatment of cancer. Then apart from that one, I can say in security making. Security making. Now under security making, you're going to find that this ultraviolet radiation is used to monitor the counterfeit banknote or banknotes. Monitoring the counterfeit banknotes. Those are the applications. Then as for Roman numeral number 3 saying, exposure to ultraviolet radiation from the sun damages the eyes. State one type of damage to the eye caused by ultra radiation or ultraviolet radiation. So the first one I'm going to say, it damages the retina. It damages the retina and the cornea. Then as for B, is saying, figure 7.1 shows a ray of light. The ray passes into a semicircular block of glass at A and leaves the glass at B, traveling along the surface to C. So now as you can see, at B, the angle which is formed there, it is what? 90 degrees. Now that angle, it is called the angle of refraction. The angle of refraction. So now, when the angle of refraction is 90 degrees, the angle of incidence, which is 40 degrees, is going to become the critical angle. The 40 degrees, which is the angle of incidence, is going to become what? The critical angle. So 40 degrees here, we are no longer going to call it as the angle of incidence, but the critical angle. Okay, so as for Roman numeral number 1 is saying, state the name given to the angle of incidence marked as 40 degrees. So it is called what? The critical angle. Okay, then the last one, which is Roman numeral number 2, is saying, calculate the refractive index of the glass. So now, since I know that, or since you know that, sine critical is equal to what? The sine angle of refraction over the refractive index. So now in this case here, we have been given the angle of refraction, which is what? 90 degrees at B. So if I say sine 90, the answer is going to be what? 1. So the formula that we are going to use is going to be like this. Sine critical is equal to 1 over refractive index. So now, the critical angle here is what? 40 degrees. So which means I'm going to say sine 40 is equal to 1 over refractive index. So when I cross multiply, I'm going to find that sine 40 multiplied by n is going to be sine 40n is equal to what? 1. So here I'm going to divide by sine 40, even here divide by what? Sine 40. So I'm going to say the refractive index, which is denoted by small letter n, is equal to 1 divided by sine 40. Of course, we are going to punch on the calculator, which is sine 40. So if I divide 1 over sine 40, the answer is going to give me what? 1.6. So this 1.6 I've just rounded off, so you can also do the same. So that was the last one. Thanks for watching.